All right, everybody, it is 11 o'clock Mountain Time. It is time for your next talk here in Track 1. My name is Jason Blanchard, and it's very nice. Thank you so much for coming back. I saw some people from the previous Track 1. Thank you for sticking around. Right now, we have Olaf Hartong. Olaf Hartong comes from the Netherlands. He's a really good friend of Black Hills. He's a good friend of ours. You participated in the 24-hour pre-show banter con-a-thon? So years ago, we had 24 hours of pre-show banter. It was the worst idea we ever had. And I will never do it again. I still have PTSD from it. And Olaf was a part of that, and that's one of the opportunities I got a chance to meet Olaf. And he is a phenomenal cybersecurity professional and wonderful human being who likes warm hugs. And I highly recommend you give him warm hugs when this talk is over. Olaf, it is all yours. Have fun telling people about all the crap that they need to figure out when they get back to work, and that they're like, another thing this guy came up with, son of a... All right, it's all you.
Thanks for that, man. Welcome, everybody. I'm not sure if you can do actually something about this, apart from sending an email to Microsoft, but I'll get to that. So Jason took most of the intro already for me, which is great. I think I had to get up at 2 a.m. to do that pre-show banter, which was probably not my brightest moment. For the people that don't know me, I'm from the Netherlands, as mentioned. I run a company called Falcon Force, where we do a lot of offensive and defensive work, and we combine that so that we can share that knowledge across teams. I'm primarily a blue teamer, which might confuse you throughout the talk. And I never went to any school to learn how to do this. I studied arts, so that's that. I had dinner with a guy yesterday, and he was also interested in getting into cyber. If you want to do this, you can do it. If you are motivated enough, try to find a mentor. There's a lot of nice people on the DEF CON side that also are willing to mentor people getting into cyber. Probably Black Hills has a similar program. Basically, that's it. So for today, there's a couple of things I want to talk about. I'm going to give you a very highlighted version of what event tracing for Windows is. I'm going to explain why security products use ETW in the first place. Why would they use this? Then I was kind of curious if I could spoof events and if I could abuse this. And of course, I'm here, so I could. And there's a couple of things that you can do with this if you're offensive, or about this if you're on the defensive side. Sadly, the defensive people will be slightly disappointed. So that's the spoiler probably for today. So a little bit about what is event tracing for Windows. So it's primarily a mechanism that is built for performance monitoring and debugging. And that's important to remember. So it's never been built for security purposes. It's heavily used for it now. But there are a couple of design features, as Microsoft will call it, that are inherently a problem for the security side of this. So it's implemented in Windows, it's deep in the kernel, and it's built for a very fast, mostly reliable and versatile way of tracing information. And it has a fairly basic architecture that consists out of 3 components. So there's event providers, so those are basically programs that can emit certain information. There's trace sessions or logger sessions. It depends a little bit where in the documentation you're reading and how they explain it. And then there's the event consumers. So these are the programs that consume the information that is emitted from a provider. How that looks at a very high level is you have all kinds of user mode and kernel mode providers. So it depends a little bit on where the program is emitting from, whether it's a kernel driver or it's a user mode application. They can register a provider and it can start emitting events. And in the middle, there's the ETW kernel or the session controller. And this is part of the NTOS kernel, which is a separate memory space. And basically how it works, let's say I'm an EDR, I'm a consumer of all kinds of information. I talk to the ETW kernel and I say, hey, I want to start a trace. And I want to have certain user or kernel mode providers attached to that. What the kernel mode what the ETW kernel will do is it will instantiate a trace session. And there are several ways of instantiating a trace session. So it can be an autologger session which starts at boot time. It can be the real-time session, which is probably self-explanatory and most used by EDRs and a lot of other security products. I can also have a file logging session, so it will just write it to a file, as the name implies. And there's also private sessions, which are kind of out of scope for now, but they're basically built for in-application tracing, so that you can actually do some performance or security monitoring within your own application. And how that looks sort of from a very high-level perspective is as soon as I have that trace command, a real-time session is created, and the ETW kernel will tell the providers, hey, you need to start emitting to these trace sessions. So these are interested in your information. And each real-time session has a set of trace buffers, which are assigned to that specific real-time session. I'll get back to that one later, but that's quite important. So of course, I'm not the first one to try to exploit ETW, right? There's many attacks about this. Probably the most common one is where you're actually patching NTDLL in the process to patch out the event write function so that it can't emit certain ETW events anymore. This is usually done for MC bypasses, but it's been used for other attacks as well. Another thing what you could do is tamper with the ETL files that are written to disk. They're in the Windows directory, or you can disable it in the registry. You can block specific events from being emitted by hooking the function of an application that you're interested in. And you can disable trace sessions in general. This is probably the hardest to do for an attacker because you need kernel level access. So you need to load a kernel driver and have it vulnerable and exploit it in a certain way. And most of these attacks require a form of elevated privilege. So that wasn't ideal for me to play with. So you might wonder now, after all my great positive things about ETW, why do security providers use it in the first place, right? So I think one of the reasons is primarily stability. So they don't need to run anything in the kernel. They don't need a kernel driver to listen to ETW information. So there's less stuff that can cause a blue screen, or machines not to boot anymore, or anything else, right? So that's one. Another one is performance. And filtering. So trace sessions can be very granularly filtered. So you can say, hey, I want to only get this event ID and this specific information from that session. Whereas if you use a kernel callback, you just get everything. And they are limited in what they can actually bring to you. Reliability. So according to the documentation, ETW trace sessions are buffered. So there is a buffer pool in there. So the likelihood of dropping events is significantly lower than if you use a kernel callback that will just blast information. If you don't process it quick enough, it's gone. So that's another reason. A big one is dynamic control. So if I'm an EDR vendor, I don't need to ship a new binary. I can just ship a new configuration because I want to tap into a certain other ETW provider that I might be interested in. And the coverage breadth is another one. So if you ever looked into what can be possible with ETW, what kind of providers there are, there's like hundreds and hundreds of them that are available, whereas if you have to rely on kernel callbacks and function hooking, you're quite limited and it's more intrusive. And that's basically what I just said to you, so that's one that I can skip. So bear in mind, and I at some point was also urged by Microsoft to mention this, this applies to every EDR. All of the stuff that I'll explain, and I'll explain where it doesn't, if it is applicable. And in this case, I use Defender for Endpoint because I use that the most, so I have the most knowledge about it, and I reverse engineered most out of that. You shouldn't be able to read this. If you do, you have really good eyes. This slide is primarily to indicate where the difference is. So on the left, the little box is where the kernel callbacks are. So where the Defender for Endpoint agent gets his information from kernel callbacks. On the right side, it's all ETW providers. So these are all the unique ETW providers that the EDR will listen to, get its information from, and use that for its whatever detection methodology it's using. And the same applies to CrowdStrike, it applies to Elastic, it applies to every EDR, because they need to get this information somehow. How that looks for Defender for Endpoint, so they get a specific configuration, what they need and don't need to listen to. So at the top you see a GUID, a global unique ID, where it is specified as the Microsoft Windows LDAP client 1. And it will have a specific event ID and some other information that it will be listening to. Another thing that you typically see for cloud-based EDRs is they have a specific capping limit, which means that after a specific amount of events, it won't send it to the cloud anymore. And this is primarily for performance reasons, cost reduction, bandwidth limitation, these kinds of things. But that can also be a problem, right? Because if I have more events than I ingest, then I don't see stuff. And I'll get into that later. So seeing that configuration makes me wonder, it's like, hey, it would be cool if I can write my own events, because then I can actually play with this, experiment. And bear in mind, I'm a blue teamer, right? So the reason why I started doing this was I need to validate my detections. And I can't always execute very high-risk attacks on a workstation or these kinds of things. But I wanted to be as close to reality as possible. So that was my primary goal. So to impersonate an attack and make the system believe it actually happened, even though it didn't. But of course, if I can do that as a blue teamer, I can also use that offensively by generating all kinds of alerts, distracting the blue team in a certain direction, and doing something else on another machine. Of course, you shouldn't do that, but you could. And another thing, since I just mentioned that most of these cloud-based EDRs, I think all of them, but I might be proven wrong if somebody knows it, they have these caps on the amount of events that they're ingesting, right? They need to process this for you, and they don't want to have terabytes of data that they need to process, because that tends to get expensive. So we can also potentially create some blind spots there. So how that kind of works. So every ETW provider is registered by a global unique ID. And any process on a machine can register it. This is by design. And this includes if the provider has been registered by another process already. So for each registration that you do, each process gets its own unique handle to that provider registration. So, and then you can use that to emit events and these kinds of things. And if you call that event register for a provider that already exists, you just get a handle to the original registered version of it. So you can register it 100 times, but you always get a handle to that first process that actually created it for you. And there's a couple of different types of providers. So there's MOF-based providers, which is basically based on old WMI stuff. So it's not that much used anymore, only on old systems like Windows 98, I think. Starting Windows Vista, they implemented the manifest-based providers, which are stored in the system 32 folder, and they're XML files. And they contain a lot of information. I have an example about that in a second. There's also trace logging providers. They're a bit newer, and they're basically self-describing. So they don't have a manifest, and they are more used for in-app monitoring and dynamic scenarios. So typically, you wouldn't see that from an operating system perspective. These manifests look a little bit like this, where you have a name, a GUID, and then some names around it. It's all great because it's XML, and I hate XML. But the other thing that they do is they have these events. So in this case, you have event ID 30, and we're talking about an LDAP client, which is a search request, which says it in the keywords. And another thing you see at the bottom with the big arrow is the template. So you can have multiple events with a similar template. So it's a bit efficient. And these templates look like this. So this is basically where you define all the fields that are stored in your event that you're emitting, or which are logged in the same way. So you can see a scope of the search, a search filter, distinguished name, like a whole lot of stuff. And this can be quite useful if you want to emulate certain events. So if you're more interested in this, there's a lot of good tools around this. Probably my favorite one is from Pavel Josifovic, and I'm butchering his name, sorry about that, where you can easily just crawl through it and see whatever the manifest contains. It has a search function which works quite well. The only thing that it doesn't do is copy-pasting, which is quite annoying. So you still have to type it or figure out another way to do it. So how that sort of works from a logical perspective. So I have my process, and I want to emit TCP events. So I call the event register function. And basically what happens is, since there was already one, I just get a handle to the original provider. And now I can start emitting events with an event write function. And from there, you can actually start emitting events that will end up in any trace session that has a consumer. So the consumer will now also get my events. That's basically what is happening. Another thing to note is that in general, an ETW doesn't note which process is actually emitting these events. So it's not stored at all. So I can just be invisible there. The only thing that is stored is a process ID of the event that was the actor of a certain event. And you can't spoof that. That's handled by the ETW session kernel. So you can't override this in any way that I found out, at least, which is a shame, because I wanted to try if it could fool the EDR to think that it was doing bad stuff itself and kill itself. But that didn't work, sadly. You can do the same for kernel mode stuff. It's a little bit harder, but the technique is the same, where you have to load a kernel mode driver, so you have to get it signed and all kinds of other stuff. It's a bit more tedious. I didn't go into this, but I've seen research that proves that the same applies. So there's some form of security around ETW. Most of it is focused on the consuming of all these events. So you can actually register a SDDL for a specific provider, where you can say which process or whatever can happen from a consumer perspective. And as I mentioned earlier, ETW originates from WMI, so the same structure kind of applies here. And you will see in the model some old WMI references. Another thing, if it doesn't have a registration of an SDDL registered for that provider, it will get a default, which is that very memorable GUID there. So basically what happens if I say, hey, I want to start a trace to a specific provider? Basically what happens is the session kernel checks the registry, so looks for the SDDL, see if I do have the permissions. If I do, it will create a logger session, which then I can consume. If it doesn't, then it will just say, hey, go away, access denied. I think you get error 5, which is also not very descriptive. So these are the permissions that you can set on a provider. So it's not that much, and you can see it's all trace log based, basically. So it's, again, implying that you can write something about consuming events. It doesn't say anything about registering to emit. If you're interested in the default permissions, this is it. You don't need to remember it. It's also very well documented. The only thing they don't say is if you look at the performance log users, again, that's mostly for debugging and these kinds of things. For some reason, if you install Visual Studio, you also are automatically added to that group, even if you're not on an elevated level. So you still get the same permissions, which in a way makes sense, because if you're a developer, you want to be able to trace all kinds of stuff on a machine. But this also allows you to trace a lot of sensitive providers. So if you're a red teamer, curious about credentials, tokens, these kinds of things, I highly encourage you to look at ETW a bit, because there's a lot of interesting information in there. So what that also means is you can also look that up, right? So there's not any tools around it that I could find, so I wrote something myself, where you can basically put it in like a provider name or service, and it will tell you if it has an SDDL registered for it or not. This is the anti-malware service, so that's part of the EDR. And basically what you see at the bottom is an allow everyone, where you can just look at all the information that comes by. And that was kind of useful for me to figure out like what kind of information is in there. And you don't need any elevated permissions to do this. So this is kind of nice. The reason why this is set, because it feels a little bit stupid, is if you are a user and you have a bug in the EDR, there is a simple tool from Microsoft where you can actually get like all kinds of information that you can submit to a ticket so that they can actually help you fix their bugs. So that's the primary reason why it's in there. If there's nothing set, so in this case I added the Windows Defender provider, then you see that you get like the default, and then everybody can register it, but nobody can monitor it. So from a provider perspective, if I try to register a provider to emit stuff, the anti-OS kernel, the ETW kernel, will check again another function internally where it will get a disallow list. I haven't found a list yet, but I know it is capable of blocking registering certain providers. But there's no documentation about this. I even had to spend a lot of time in IDA to find these calls to see it happening. But it's happening somewhere in memory, and my kernel debugging skills are very terrible. So I didn't get the list yet. But I know at least one provider that is on it, so I can replicate it. If it's not on the list, you'll get a handle and you get to emit stuff. So it's the same as before. So with all that stuff out of the way, I wrote a very basic POC in Go to actually start emitting some LDAP events. I built it based on a couple of open source packages that I found. And I ran into some issues there because they, as you can see, they're only focused on consuming events. And emitting something, they allowed it because the POC worked, so I was very happy. I saw it in like a handy trace there, but it never happened. It never ended up in the EDR, so that was kind of disappointing. I spent probably an hour waiting for it because sometimes there's some delays, but nothing happened. So after a while, I started diffing all of the recordings from a real event and my own event. First thing I learned, since I'm not a developer, is that most of the Windows stuff that you write is in little endian, and I wrote it in big endian, so of course that didn't work. But another thing I learned is that all these pre-built packages didn't give me any control over the headers that I emitted. So these events look a little bit like a PCAP in a way, but I had to set certain headers that weren't opened by the packages. So basically what I did is I scrapped everything and followed the syscall approach, which was not easier, but it at least allowed me to write a lot of stuff. So I built a new POC, I emitted some stuff. I could see that it actually was recorded by the operating system, and a couple of minutes later it also ended up in the EDR in the raw logs. So I was kind of happy about that. So since I had that POC running, I was kind of interested in, hey, okay, now I have this, what can I do with this? So going back to that capping that I mentioned earlier, one of the things that you see here is a capping of 1 with an LDAP first seen. So basically what that means is for every process that has a search for a specific search filter and a specific distinguished name, you only get 1 log event per 24 hours. Again, reason primarily performance, but this is also very annoying if you're a detection engineer. You're testing your attack a couple of times because you're playing around with it, and you only get one log entry, and you're wondering why the F you don't see the rest. So basically what I did is I ran my binary, then I renamed it to Canary just to see if that would change anything. And both ended up in the logs, right? Because the binary name is different. If I would have ran the same binary twice, I would only get 1 log entry for that. So then I figured, okay, now let's see. I was lazy, so I just generated random strings as search filters and distinguished names. And I started running a lot of random queries. So in this case, I ran 10. All 10 ended up in the EDR as well. So then I figured, okay, now let's see about that global cap. So the global cap basically implies that on the whole system, there's only 1,000 events logged for the LDAP queries, right? It's per provider. So, of course, I emitted a little bit more than 1,000, and I started looking in my EDR, and I actually only got 1,000. So that was cool. So basically what I figured out is, okay, now what happens if I send another process with another query? I call it real canary this time. and I executed it, and nothing showed up. So my hypothesis was true, the canary is still alive, and I could basically figure out ways to now blind an EDR to the real stuff I'm doing. So the technical attack would be to first run 1,000 random strings as query, or whatever you want to do. You can also do full text strings, and then do your Sharphound or your AD Explorer collection. And at least from an endpoint perspective, nobody would see it. So that's basically this. And that means that no telemetry is no detection. So the EDR relies on the same data that you can query. It has a bit more, but that's not exposed for querying, but it's whatever is set in that configuration that I showed you earlier, that's basically the limit also for the EDR. So if I don't see it, the EDR also doesn't see it, so no alerts. So as an experiment, I also created a buff for the same things, because it can be useful. And that works in the same way, right? It's just a different level of execution. You need code execution, of course, on a box, but that's usually not the hardest. And you can have some fun with this as well. So depending on how the organization has set up their conditional access policies, there are ways where they sometimes block a user from accessing their resources if they have a high or a medium risk to them. So if I manage to generate certain alerts on a box, then they will yeet it off the network, right? So they can't have access anymore. And the same applies to Intune. So you can set it to if a device is not compliant, that it can't access the company resources, which is good practice. You should maybe look into this, because it's actually super valuable. But you can also abuse this if you're an attacker that is a bit devious. Of course, nobody is like that here, but you could. So be mindful of this. So another thing that I was looking into is that anti-malware service one that I showed you earlier, that has the same capping limit. And a lot of them have a capping limit of 1,000. They are, in almost all cases, for 24 hours. So one of the things I figured out is also I can emit random AV alerts. So I have a lot of hack tools and viruses and all kinds of things that actually exist, but with fake file names and that kind of stuff. So I emitted all of these, and only 1,000 were logged. So the other 2 are for the day before. So that was sort of my bad on the query. So that, again, will be useful sometimes for testing, but also for kind of confusing people. And if I can do viruses, I can also be a ransomware operator now, right? I figured out that I could also have like legitimate detections for ransomware. And they actually started generating alerts as well. And this is something that an analyst would see. Maybe not the best day of their career if they see this. So don't use this. But again, you could do this. You could get people blocked off the network, but you can also cause a small panic where they're escalating and are super distracted, and you're doing other stuff. And I could do the same with all kinds of other AV detections. So I figured, okay, this is bad. I need to do something about this. So I wrote a letter to Microsoft. I did the research end of last year. I wrote it somewhere in the beginning of this year. And I included a POC tool, and this is important, only for that anti-malware stuff. So the ransomware and the fake AV detections. I gave them a list of all the 100 or 99 other ones, so that they were aware that I could do this to all of them. So 2 weeks later, I got a message back. It's like, this is not that important for immediate servicing, so thank you. And at some point, the product team will look into this. And then at some point, I thought, okay, that's case closed then. I mentioned that I would talk about it at Black Hat and maybe other conferences. So that was it, or not. So right before my Black Hat talk, I started to create some demos. And I did the same thing. I emitted all kinds of ransomware. I saw the logs coming in. And then it didn't get alerts anymore. It's like, hey, this is interesting. So they fixed stuff. I was happy. And then I started looking a little bit longer. It's like, well, maybe not. So I started doing my LDAP searches. So I built like a fake Sharphound, I built a fake Certify, I built a fake AD Explorer in terms of the telemetry that they generate. And I would still get alerts there, right? So apparently they only fixed a little bit. So they only fixed the ransomware emission bit that I created, which was kind of disappointing. I don't want to join this meeting. What they also did, was even funnier, is they wrote a AV signature for my POC, which is kind of hilarious, sort of maybe a compliment. So basically what I had to do is obfuscate all the strings in my binary, and I ran it again and it worked again. So AV evasion passed. And then I got an email from Microsoft because they figured out that I was talking at Black Hat. And they, at some point, mentioned, after chasing me for my slides several weeks, that's like, yeah, we're working on a fix, and the deployment is expected on August 7th. My talk was August 6th, so it was, of course, very accidental. Anyway, and the rest was a bit vague, and it was very annoying to get like some details out, and at some point they were like, yeah, the focus is only on hardening Defender, the rest is not really our problem. So I tested it the day before my talk, and I tested it again a couple of weeks ago, I tested it again a couple of days ago, and basically what they did is they applied some protections, but I could still emit fake AV detections, I could still inject MC events, but I couldn't inject my ransomware stuff anymore, which was kind of interesting, because I got an access denied from the ETW kernel directly. So they basically had 100 problems, they still have 99. They only fixed one, which was kind of sad, because I gave them everything that they needed to actually work something with it. So I sent them another emails like, hey, great, you've applied a patch, but not really. And they gave me this statement. So at some point, they might look into more. And they were. So one of the things I also do is I have no life apparently, so I take the new configurations from the vendor every day and I diff it and see if there are differences. So one of the things I also noticed, like a couple of weeks after my talk, is that they started looking for capped events and dropped events and filtered events and all these kinds of things. So they're building some internal telemetry where they can see if somebody's fiddling with it. I spend a lot of time trying to get it to trigger something. It doesn't do it yet, but maybe it's still in the works. So there's stuff being done. Another thing that I noticed is they at some point killed another provider. So they only have 98 problems, I guess. So there is some effort, but again, all the efforts are focused on the vendor, because that probably harms their image more than if I do TCP events that nobody cares about. So when building that talk, I was also curious about these buffers that I mentioned earlier. So I started looking into these buffers a little bit. As I showed earlier, every time you create a trace session, there's a buffer pool assigned to it. And basically what you can do there is you can assign a specific limit. So there's a buffer size that you can configure yourself if you start a trace session. By default it's 64K, but you can bump it up to 100 or to 1 megabyte, sorry. And you can also set a number of buffers and some other information. And this is all non-page memory in the kernel, so you can't really do buffer overflows or get all kinds of code execution or other exploitation with it. And if you're curious what that looks like, you can just use Logman, which is a normal Windows utility, to actually get these details out. So then I was curious, so like what happens if I fill that pool, right? That's the best GIF I could find. So basically how that happens is these buffers just allocate a certain amount of blocks, which are part of that pool. And as soon as some of these providers start emitting events, they will end up in the pool. And at some point there's enough. And then the consumer gets the information out and the pool gets flushed. That's how the design kind of works. Of course, there's more details to it, but that wouldn't fit in a nice diagram like this. So then I was curious what happens if the pool is full, right? So one of the things that happens, and this is by design, and this is very poor design, basically what happens is the ETW kernel will tell every provider you can't emit anymore because the pool is full, right? You're not welcome. Which sounds okay, but the problem here is that it will tell it to the provider that it can't emit, period. So if I have two trace sessions, what you see in the diagrams, like the top one is the EDR, bottom one is mine, the provider can't send information to any trace session. So also the EDR is blind here. So I wanted to test this. So I wrote a simple script that could like blast as many ETW events as I wanted. I started a real-time trace session with a 1 megabyte pool. And I was a bit lazy, and I didn't think it through, so I connected it. I didn't connect it to a consumer. So I just started a trace session like you would do on a normal way. And I didn't connect consumer to it. So there's also no way to monitor this. So I built a tool called ETWmon, or providermon, sorry. And on the left side, you see my tool just blasting it information. On the right side, you can see my LDAP trace at the bottom, and you can see the number growing and growing on the failed side, on the lost side. So nothing is consumed. So that's a kind of concern, right? Because if I can make it blind for one provider, I can make it blind for any consumer as well. So I created a tool for this, so it's called Bamboozle EDR. What it allows you to do is you can emit events for all kinds of providers. You can hit at least the Defender for Endpoint capping, because I'm quite familiar with those. Probably it works on other EDRs as well, but sometimes you might need to bump the cap a bit, just set it to emit more. You can also simulate like Sharphound and these kinds of attacks. And it also allows you to start that trace session without a consumer. This is the only one where you do need elevated privileges for. All the other stuff is user mode, unelevated. And there's a flooding feature in there that will allow you to just flood any EDR provider that I have programmed into it with information. So it will either fill the pool or it will exceed all the capping for it. So that's interesting, of course. So what can you do about or with this as a defender? So of course you can craft all kinds of telemetry that you can then use to test your detections, which is super useful. Another thing you might want to look into is build a detection for a machine starting to log like a crazy amount in certain tables and then nothing, which shouldn't happen. Another thing maybe is to build a custom tool to monitor these provider registrations. And this is very possible, but it's going to be very noisy. I built Profmon, which is a tool that only looks for provider registrations, and it allows you to send that to a JSON file that you can then ingest into your SIM. But this is going to be noisy per machine. It's like hundreds of megabytes of information, because this is happening a lot on a normal system as well, right? It's not only attackers doing this. So basically your best resort is maybe not hope, but chase Microsoft to properly fix this. Because this is a design flaw in the ETW kernel. This is something that they need to address. As an attacker, you have more options, right? So you can play around, you can try to evade that cap, so that at least for 24 hours, the EDR is blind. You can also, if you have admin privileges, use that buffer flooding option, and then it basically lasts until the machine is rebooted. So there's no telemetry until the machine is rebooted again, and then it will start logging from that point onwards, right? So the rest is lost. And of course, you can emit fake events and maybe annoy the blue team a little bit, or distract them enough. And if you're a little bit more lucky and they have proper conditional access policies, you can actually also yeet them off the network if you want to do that. Another thing that I didn't talk about is also the amount of trace session has a limit of 64 on any Windows machine. So if you register 64 trace sessions, well, there's probably a couple already. Nothing else can get additional sessions on that system. So that's another kind of interesting fact. So this is not AI, and it's very disturbing. So sorry about that. Not about the picture, but at least your trust in logs is a little bit broken. And I was also checking with Pavel quite a lot because he knows way more than I do about this. He has a very specific opinion that I can relate to, but I don't agree with, because there's no other way to get this telemetry. I think the most important bit here is to be mindful that people can tamper with your logs, right? So most of the defenders are used to trusting whatever is logged that happened, right? It's true. And most of the time that is true. But I also showed that it can be not always true. And this doesn't only apply to an EDR, right? I can do the same to a SIM, because the SIM also looks at a lot of ETW stuff or event logs which originate from ETW. So that's the same. But at the same point, all these events are great for detection, and there's no easy way or no way at all to actually collect it in the first place. So yeah, there's also a bit of a weird conclusion that the EDR needs it, but they also need to improve the security of it, and this is again Microsoft's problem, and they need to do something about this. They promised me they would look into it, but while I trust their efforts, it's also they need to make changes in the kernel, which they're not very eager to do, for mostly the right reasons. So yeah, we'll see. Maybe something changes. There's a lot of really, really smart people that I relied on to validate and get some other information from. Probably the most important one is Jeff, who sadly is deceased, but his website is still on. It's a very old-fashioned website, but it's a treasure trove for anybody looking into Windows internals. So it's probably the most valuable thing I used. I created a lot of tools to get to this research. They all have their own little specific use case. I don't like monoliths, so I try to build tools for everything. Keep in mind that some of them are POCs, so they're not really good, properly written. Definitely use some AI to write some of those. They work. Don't use them in production. Use them for research. So at the same point, I was doing some additional research. And that might be on the next Wild West Hacking Fest in Denver. I submitted, but I haven't been accepted. Doesn't matter. At some point, I figured out that I could also talk to the cloud without even getting code execution on a box. So I can have fake devices emitting fake data. So I have full control over it. I also didn't report it to Microsoft yet. Well, they might know it now, right? But that's okay. So that's something I might talk about at another conference. And with that, I'm done. And hopefully there's questions. Do you have a mic for you, or no? All right, just shout. Oh, so the question is if I found other stuff where Microsoft was reluctant or slow to fix it. Sadly, yes. I have another exploit that I found probably 4 years ago now about a misimplementation in Defender application control, which is on every Windows machine, where you could kill any EDR with it. They acknowledged it. They even wrote a patch for it. But the patch is still pending till some threat actor uses it. That's the sort of verbal response I got. So 4 years. So, and I've seen it being used in the wild. So it's I don't know. Sometimes it's hard. They're very reluctant on the kernel side to make any changes for stability and backwards compatibility. And there's thousands of reasons which I can relate to but not agree with. Yes. Yes. So the question is if the EDRs are moving away from the kernel into user land, if that would help. For this, sadly not, because I'm also emitting from user land and I'm not even touching the kernel. For other things it may, but it also might grow the attack surface for my technique, since in user land you don't have kernel callbacks that an EDR still relies on for process creation and some other events, which I can also spoof by emitting into their ETW provider respectively. So it will primarily help stability, and hopefully they will redesign the kernel in a way that's less possible, while the EDR can actually use it in a better way. I think Apple has a really good example of how it can be better. It's not perfect because there's no documentation about it, but it's at least more stable. Yep. Yes, Eric. Ah, that's a good one. So if I've seen my technique being used or abused by main actors. Well, the problem here is that you can't see if somebody's using it. But that said, I've been informed that there are nation states that have this capability. And I've been helping an incident response company recently also that had similar behavior where the EDR would stop logging, stuff happened, and then it started logging again. So, yeah, of course, if I can find it, there's way smarter people that can do the same, right? Of course. Oh, no, I haven't seen any capabilities in other codes. But I'm also not a malware reverser. So it's likely that somebody's seen the talk or has my GitHub. The only thing that I tried to do, at least with the Bamboozle EDR tool, is I wrote it in a way that it's not super easy to implement it directly. So at least you need to have either a very good AI assistant or you have to do something with it. So it's primarily built for research purposes, but of course a smart person can just run with it. There's one more. Yeah, so the question is if I've seen these capping being triggered, sorry, capping being triggered by normal Windows processes. So if you still can hear me after that nice squeal. Yes and no. So the global cap I have not seen being triggered by noisy Windows stuff. The local cap for sure. And that by building detections is freaking annoying because if even a network connection is logged once for a process per 24 hours to a specific destination, so if you have a beacon running that checks in every whatever, you only see it once, and that same applies to a lot of other processes. And if you're testing stuff, then you will have blind spots for yourself already. And even me knowing about this feature, sometimes when you're really into it, you forget about it. So as an analyst, it sucks. Yeah. If there's nothing else, then thank you. Have a great day.